Good morning, everybody. So today I am going to start with the topic partial differential equations of first order. So here you are going to study the formation of partial differential equations and solution of linear partial differential equation, that is known as Lagrange's equation, then a non-linear first order partial differential equations, and then a Charpit's method. Okay, so in this unit these are all the topics you are going to study in this unit. So first we should see what is a partial differential equation. Okay, so before that, first let us look into dependent and independent variables. I think you all are aware about the dependent variable and independent variable. Okay, so now consider these equations. So first y is equal to x plus 3, then second y is equal to x raised to 4 plus 3x cube plus 2x square plus 5. So it is a polynomial equation of fourth order and it is a polynomial equation of first order. Then it is a trigonometric functions, so which involves a trigonometric equation, okay, or it is also called as transcendental equation. So in all these equations, what happened, if you want to find the value of y, we need x value, correct? So if you substitute x equal to 1, then you will get y as 1 plus 3, 4. If you substitute x equal to 2 here, then 2 plus 3 means 5, the value of y is 5. Then if you substitute x equal to 3, then you will get y is equal to 3 plus 3, 6. Okay, so that means if you want to know the value of y, or if you want to find the value of y, we need the value of x. That means the value of y depends on the value of x. If you don't know the value of x, then we cannot find the value of y. So here, and we say that y is dependent on x, but x can take any values. Say x equal to, it can take 0, 1, 2, 3, 100, 1000. So it can take any value. That means it does not depend on any other variable for its values, right? So it can take its own values 1, 2, 3, 4 and 100, like that. So x is called as independent variable, whereas y, it depends on the value of x. So therefore the y is a dependent variable and x is an independent variable. Similarly here also same thing, y is equal to x raised to 4 plus 3x cube plus 2x square plus 5. So here x is independent variable, y is dependent variable. The same case in the third example, so that is x is independent variable and y is dependent variable, because y depends on the value of x. Now similarly here, y is equal to x plus 3 by x raised to 4 plus 3x cube plus 2x square plus 5, and y is equal to sine square x plus log x plus sec x tan x. So in these two problems, again x is independent variable and y is dependent variable. So because y depends on the value of x, if you want to find the value of y, x value is needed. If you don't know the value of x, then we cannot find the value of y. So therefore y is dependent on x. So we say that x is independent variable and y is dependent variable. Now in all these examples, so these three examples. Okay, so they are represented by one common equation that is called as y is equal to f of x. Y is equal to f of x means what? Any expression, y is equal to any expression containing x. So all these are expressions. So x plus 3 is an expression which contains x, and this is also an expression which contains x, and this is also an expression which contains x. So we denote all these equation by y is equal to f of x. So here x is independent variable and y is dependent variable. Okay, so next we go to ordinary differential equation. So ordinary differential equation means what? So here in this case, now consider this equation. In this equation, how many independent variables are there? So here x is the only independent variable. X is the only independent variable. That means only one independent variable in this equation. Similarly, take the second problem. Here also we find only one independent variable. Here also we find only one independent variable, that is x. Okay, so next we go to another example, and similarly here also in these two examples, this is x, only one independent variable x and only one independent variable x. So that means in ordinary differential equation, this is known as ordinary differential equation. So in ordinary differential equation, there exists only one independent variable in ordinary differential equation. So first we should know what I think you might have studied differential equation and ordinary differential equation, right? So ordinary differential equation means what? There you have only one independent variable, Okay, so now these are called as ordinary differential equations. Next we come to the partial differential equation. So partial differential equation means what? So partial differential equation means it is a differential equation. It is a differential equation which involves more than one independent variables. Okay, it involves more than one independent variables, and then a dependent variable and its derivative. It is called as the partial differential equation. Okay, so now in this example, now see here, this is first example. So it is given by dou square u by dou t square equal to dou square u by dou x square. Now see here, how many independent variables are there? There are two independent variables. One is x, another one is t. One is x and another one is t. So this is a partial differential equation which is called as wave equation. Wave equation means it is used in solving heat conduction problems, which comes in mathematical physics, right? So there we are going to solve heat conduction problems. So for heat conduction problems, so this equation is used. So this is known as wave equation. Now consider the second example. Dou u by dou t is equal to dou square u by dou x square. Again in this example, there are two independent variables. One is x and another one is t, and it is called as heat equation. It is also used in heat conduction problems. So all these equations, wave equation, heat equation, Laplace equation and Poisson's equations, all these are used in mathematical physics, that is in heat conduction problems. So next, take the third one here. It is dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square equal to 0. So in this again, there are three independent variables, x, y and z. X, y and z. Okay, so similarly here, last example, in this also there are three independent variables, x, y, z, and one dependent variable, okay, and derivative with respect to independent variable. So therefore these are called as partial differential equations. Partial differential equations. All these are examples of partial differential equation. Okay. So this is about partial differential equation. Next we go to classification of partial differential equations. So partial differential equations are classified in three types. So one is a semi-linear partial differential equation. So semi-linear partial differential equation means what? It is a first order partial differential equation where it is linear in A and B. It is linear in A and B, and coefficients of A and B are functions of x and y. X and y only. Next comes quasi-linear equations. Quasi-linear equation. So it is a first order partial differential equation. So it is linear in A and B. It is only linear in A and B. Next comes non-linear equations. So it is a first order partial differential equation where which does not come under these two categories. These two categories means either it is semi-linear nor it is neither it is semi-linear nor quasi-linear. Okay, so then it is called as non-linear equation. If it is not semi-linear and it is not quasi-linear, if it is not both semi-linear and quasi-linear, then this is known as non-linear equations. Non-linear equations. So this is all about partial differential equations. So now we go to formation of partial differential equations. Formation of partial differential equations. How to form a partial differential equations. So partial differential equations can be formed by either by eliminating arbitrary constants or by eliminating arbitrary functions from a given relation. Okay, so here we use some notations. This is for just our convenience. So those are, first one we take it as P is equal to dou z by dou x. P is equal to dou z by dou x. So this is one notation. Next we take Q is equal to dou z by dou y. Q is equal to dou z by dou y. So here this dou z by dou x is denoted by P, then dou z by dou y is denoted by Q. So here P and Q are not constants. Remember, P and Q are not constants. So P is dou z by dou x, Q is dou z by dou y. Similarly, we have another notation, that is dou square z by dou x square, which is equal to R. Then dou square z by dou x dou y, which is equal to S. Then dou square z by dou y square is equal to T. So all these notations we use while solving a problem or while forming a partial differential equations. So P means dou z by dou x, Q means dou z by dou y, R means dou square z by dou x square, S means dou square z by dou x dou y, and T means dou square z by dou y square. Okay, so this is all about introduction to partial differential equations. With this I conclude this class. In the next class we solve the problems on formation of partial differential equations. Thank you.